So hello everyone, welcome to this new session. So yeah, till now we have discussed all the homogeneous, non-homogeneous and all the type 1, type 2, type 3 mixed type problems. So now we have left with the two more important concepts of this module. So very important concepts, okay, that are, the first concept here is Cauchy's homogeneous linear differential equations, okay. So here in this Cauchy's homogeneous equations, we have few changes in order to solve the complementary functions and the particular integrals along with the general solutions, okay. So here this Cauchy's homogeneous equation is of the form a naught into, we have an extra term which is added here is x power n minus 1 and x. So these x power n are the variables that are the highest degree, that are of the highest degree form. For example, we have a constant term, along with that we have an x term. Till now we didn't had these x terms, right? X power n minus 1 x, okay. So we have in these kind of equations, these terms are added, okay. So in order to solve these kind of equations, what we need to do? So here we can say that these a0, a1 and up to a power n minus 1 are all are constants, okay. So these equations are called as Cauchy's homogeneous linear differential equations of order n. So in order to solve these kind of equations, so till now we were doing is that we need to take all the d square terms outside, but here along with the d square terms, and we need to add the constants along with the y term we need to keep outside, right, in order to find the complementary function. So here we have these x terms common here. So now what, in order to find these complementary functions, what we need to do here is we reduce this equation to linear equation with constant coefficients by some of the substitutions, okay. So what we need to substitute is, wherever there is x, right, we need to replace the x terms by e power z in the whole equation. And also we need to replace, wherever there is log x terms, we need to replace all the log x terms by z, okay. Again I repeat what we need to do, wherever there are x terms we need to replace it by e power z, and wherever there are log x terms we need to replace it by z, okay. Also there are few more substitutions, that is, for example, if in an equation, if the equation is of the form x into dy by dx, for that we need to write it as dy, okay. Till now what we were writing, that is dy by dx, we were writing it as d, right, and d by dx we were writing it as d, okay. But now x into dy by dx should be replaced by d into y, and x square into d square y by dx square should be replaced by d into d minus 1 into y, okay. And x cube into d cube y by dx cube. See, wherever there are square or cube terms, the similar order of derivatives would be present along with those x square or x cube terms, okay. For that we need to replace x, whenever there are cube terms we need to replace d into d minus 1 into d minus 2 into y, okay, in the given equation. The first step is we need to replace these equations, okay. After that we get the final f of d of y is equal to r into e power z, okay, where this e power z is equal to x, right. So this corresponds to r of x only, where r of x is replaced by r of e power z, since we need to substitute x equal to e power z, right, which is the function of z. So whatever we write, the complementary function should be of the function z, okay. Till now we were writing it in the order of x, right. So now we need to replace the function by z. So this was all about Cauchy's homogeneous linear differential equations, okay. So in this session we will solve few simple problems so that you will be clear about the concept, and trust me, these are very easy. You need to just understand the concept, okay. Since we have solved so many problems related to differential equations, these problems which we are going to solve would be easy for you, okay. Yeah. Okay, so this goes your first problem of Cauchy equations, that is x square into d square y by dx square minus x dy by dx plus y is equal to log x. So this is a very simple problem, okay. So first step is that we need to do some substitutions, right? That is, we need to substitute x square d square y by dx square is equal to what? D into d minus 1 into y, right? And also x dy by dx as dy, right? Also we have this log x, right? This log x term also in the conditions we have seen that we need to replace log x by z, right? And also x by e power z, but we don't have any x terms here, right? So we need to replace log x and x only in the r of x side, okay, not in this equation, okay. That also you need to remember. Okay, after this substitutions, now write the whatever you have substituted, write those terms first. That is, this term would be now d into d minus 1 y minus x divided by dx is equal to dy plus y is equal to log x is equal to z now, right? That is, so now again d into d minus 1 minus d plus 1 into y is common, right, is equal to z. So that is equal to d square, multiply this d to this term, that is d square minus d plus 1 into 2 y is equal to z. So this would be now d square minus d is minus 2d plus 1 into y is equal to z. See, now we have finally, after doing some of the substitutions, we have reduced it to the form where we were solving it before, right? Like d terms we have got, by solving here we got the term f of d, right, by doing some of the substitutions. Yeah, so this way we need to solve this. So now rest of the steps you know, right? We have solved many problems, right, till now. You need to be knowing, if you are following my classes regularly, you might be knowing that we have solved more than 10 to 15 problems, okay. Yeah, so now we need to replace d by m, that is m square minus 2m plus 1 equal to 0. Find the roots. The value of b is minus 2, so minus into minus 2 is plus 2. Minus 2 the whole square is 4, minus 4 into a into c is again 4 divided by 2. So m equal to 2 plus or minus 4 minus 4 is 0 by 2. So we get m equal to 2 by 2 comma 2 by 2, right, since we have plus or minus 0, right? So our total roots are 1 comma 1, right? So now we get the complementary function as, since the roots are distinct, which are repeating, c1 plus c2x into the root is e power, no, now the function we have in the definition we have told that it's of the order e power z, right? So now wherever there is x term, we need to replace it by z, because this is a function of z, okay. Yeah, so this is our complementary function. So now again we need to find the particular integral. The formula is 1 by f of d into r of z, okay. So now again it should be replaced by z, okay. Yeah, so now our particular function would be, the value of r of z here is z divided by f of d is d square minus 2d plus 1. So here there is only z term. So here we can see that this z term corresponds to the type 3 problems, that is the polynomial. This is a monomial term z, right? So we need to rearrange the terms. This numerator remains as it is since we have only one term, and the denominator should be in the ascending powers, right? So we need to reverse these terms, 1 minus 2d plus d square, and now solve using this division method. Write 1 minus 2d plus d square outside and z inside, and consider this 1 and z. So we know that in order to get the answer as z, we need to multiply 1 into z, right? So 1 into z, we get it as z, right? Yeah, write z. So now minus 2d into z. So we need to minus 2 into differentiation of z is 1, so the answer we get it as minus 2, right? So now replace the signs. So this would be minus, so here there is minus, so this would be plus. So this is plus 2. So 1 into how much will give you 2. So this is straightforward division. We know that 1 into 2 plus 2 is equal to 2, right? So write plus 2, change the sign, it would be 0. So here our particular integral we get it as z plus 2, right? Yeah. So now our next step is that we usually write the general solution, right? So now here we should not write the general solution, okay? General solution, we have one more step to do in order to write the general solution. First we will write what is y, that is yc plus yp, right? Yeah, so what we get yc we got it as c1 plus c2z, okay? I've written in the complementary function while solving, I've written it x, right? So replace by z, okay, into e power z plus the particular integral we got it as z plus 2. So this would be our final answer, okay? Our final answer always, right? But in this case this is not your final answer. We have one more step, that is we have here in, if you observe carefully, we have z and also we have e power z terms, right? Z and e power z terms. But according to the condition of our Cauchy's equation, we need to replace, wherever there is z, we need to replace it by log x, right? And wherever there is e power z, we need to replace it by x, right? So in order to write the final general solution in terms of x, we need to do these two substitutions for the Cauchy's homogeneous equations, okay? Yeah, so now finally our general solution would be looking like this after replacing these terms. This y is equal to c1 plus c2 into, in place of z we need to write it now log x, right, into e power log x again, right, plus z is written as log x plus 2, right? Yeah, so here we know that exponential and log term gets cancelled each other, right? So our final general solution would be looking like c1 plus c2 log x into, the remaining term here is x, right, plus log x plus 2, okay? So now this is our general solution where all the functions are in the x terms, okay? Yeah, so this would be our final general solution. So this is not your final general solution. After this step we need to replace, wherever there are z and e power z terms, we need to replace it by log x and x respectively, and after that we need to substitute those values, and finally we write the, after few simplifications, write the final general solution, okay? Yeah, so in this way we need to solve these problems. So we are going to solve one more question in this session. I'll get you the question. So this is your second question. This looks a bit complicated, but it's very easy, okay? Yeah. So again we have x cube d cube y by dx cube plus 3x square d square y by dx square plus x into dy by dx plus 8y is equal to 65 cos of log x. Okay, so now the first thing we need to do is we need to substitute few terms, right? So here first thing, let's substitute x cube d cube y by dx cube as, what we can write it as, d into d minus 1 into d minus 2 y, right? So x square d square y by dx square, we have this term here, right? That is equal to d into d minus 1 into y, and x dy by dx as, we write it as dy, right? Along with the, we have in the r of x term we have log x, right? So we need to replace log x as log x is equal to z, okay? Yeah, so now let's solve this. That is, write the substituted terms, d into d minus 1 d minus 2 into y plus, we have 3, right? First write 3, along with that d into d minus 1 into y plus dy plus 8y is equal to 65 cos of, so in place of log x now it is z, right? So 65 cos z. Okay, so now solve this. So d minus 1 into d minus 2, solve this, that is multiply d into d square minus 2d minus d, that is minus 3d, minus 1 into minus 2 is plus 2, 3 into multiply this d, that is d square minus d into y plus dy plus 8y is equal to 65 cos z. So again multiply all these terms, that is multiply d to this term, d cube minus 3d square plus 2d, and multiply here again plus 3d square minus 3d plus 1 plus 8, right? Sorry, plus d, this is d, right? Plus 8 into y is equal to 65 cos z, right? So here we can see that minus 3d square plus 3d square we can cancel, so we can write it as d cube 2d minus 3d plus d. So 2d plus d is 3d, and 3d minus 3d is again we can cancel these terms, so the left out terms are d cube plus 8 into y is equal to 65 cos z, right? So now for this we need to, again the same thing, we need to replace d by m and we need to solve for complementary function. Yeah, so we'll continue now. This would be m cube plus 0m square plus 0m plus 8 equal to 0, right? So again this is of the form cubic form, so 1008 are the coefficients, so we need to find the root. I've written the equation in the calcs. So now find the roots. First put 0, 1, minus 1, 2, minus 2. See, we got, for minus 2 we got the root as 0. Minus 2 into 1, minus 2. 0 minus plus 2 plus or minus 2 is minus 2 into minus 2 is plus 4. 0 plus 4 is 4. Minus 2 into plus 4 is minus 8. 8 minus 8 is 0. So we'll get m square minus 2m plus 4 equal to 0. So now for this, solve this, the value of b is minus 2, so 2 plus or minus square root, minus 2 square is 4. 4 4 is 16. 4 minus 16 divided by 2, square root of 4 minus 16 is minus 12 by 2, square root of 12 I square, since there is minus, so 12 into I by 2. Continue here. So we can split this 12 and write it as 4 into 3 I by 2. Okay, so that we can write the square root of 4 is 2 root 3 I by 2. So here in the denominator we can take 2 common and write it as 1 plus root 3i, 1 plus or minus root 3i by 2, so that we can cancel this 2. So the left out term is 1 plus or minus square root of root 3i, right? So the total roots are minus 2 comma 1 plus or minus square root of root 3i, right? So now our complementary function is of the form. The first root is minus 2, c1 e to the power minus 2. The function here is now not x, right? Z, okay? Plus c2 cos beta is root 3 z plus c3 sin root 3 z again, e to the power alpha is plus 1 e to the power z, okay? So this is your complementary function. So now the same way we need to find the particular integral, that is the r of x is now 65 cos z divided by d cube plus 8. This again is of the type 2 form, cos ax. this is actual cos AZ. The value of A here is equal to 1, so we need to replace d square by minus of 1 square, that is minus 1. So IP is 65 cos Z. Since here we have d cube, so we can write it as d into d square plus 8, so that we can substitute for d square. 65 cos Z divided by d square is also minus d plus 8, right? So multiply the conjugates, both numerator and denominator. Minus d minus 8, right, divided by minus d minus 8. Okay, this is minus. Okay, yeah, so now multiply it. So minus 65d cos Z minus 8 into 65. 65 8s are 65 8s are 8 5s are 40, 8 6 are 48 plus 4 52, 520 cos Z divided by, this is again of the form a plus ba minus b, that is minus d whole square minus 8 square. Minus 65 into, the derivative of cos Z is minus sin Z. 520 cos Z divided by minus d whole square is d square minus 64. So our yp is minus into minus plus 65 sin Z divided by d square minus 64 minus 520 cos Z d square minus 64. Again replace d square by minus of a square, where the value of a is equal to 1, so minus of 1 square equal to minus 1. So our yp would be looking like 65 sin Z divided by minus 1 minus 64, 520 cos Z divided by minus 1 minus 64, right? So yp is equal to 65 sin Z minus 65 sin Z by 65 plus 520 cos Z by 65, right? So this 65 gets cancelled, so 65 1s are and 65 8s are, right? Right now we have solved for 65 into 8, right? Yeah, so we get yp as, well, at the first positive term 8 cos Z minus sin Z. Yeah, that's it. This is your particular integral. So now we can write y is equal to yc plus yp first, that is we get y as, so what we got, the complementary function c1 e to the power minus 2z plus c2 cos root 3z, c3 sin root 3z into e power z, right, plus 8 cos z minus sin z. So this is your y term. So now again we need to do some of the replacements, as I have told you, right? We need to replace e power z by x. Also log x we need to write it as z, right? So now y would be looking like c1 e to the power minus 2, wherever z is there, you should replace it by log x, plus c2 cos root 3 log x, right? c3 sin root 3 log x. Be very careful while writing the terms, okay? Check each and every terms. Into e to the power log x again, minus 8 cos of plus 8 cos of log x minus sin of log x, right? So now we can simplify few of the terms. So e exponential and log here gets cancelled. So here we have minus 2 log x, right? This is of the form of where I write here b log a, right? We know that b log a is equal to log a power b, right? So the same thing we are going to do it here. So this we can write it as e to the power minus 2 log x, right? You can write it as e to the power log x minus 2, okay, where we can cancel here e and log x. We are left with x to the power minus 2. That also, that we can write it as 1 by x square, right? So this, the first term will be looking like c1 into 1 by x square, right? That is c1 by x square. Write it directly, c1 by x square plus the rest of the terms remains as it is, c2 cos root 3 log x, c3 sin root 3 log x into e and log it cancelled, only x remains, plus 8 cos of log x minus sine of log x. So this is your required general solution. Okay, so this much big is your required answer. But if you know these steps very clearly, you can solve it very easily. Okay, the thing is that we need to observe each terms very carefully and solve these kind of problems. Okay, yeah, so that's all for this session. So we are going to continue with this Cauchy's problem in the Cauchy's equation problem in the next session. Okay, we have still more 2 important problems, so we'll continue in the next session. Thank you.